In this demonstration, we are going to show how we can control a rover with a joystick, industrial grade joystick, and make it go forward, reverse, and tank clockwise, counterclockwise. And this is going to be done through the networked robotics, the networked robots that we've set up. Basically, we have the frontline server, frontline TCP/IP server, which has made a connection to the rover, and you can see the blinking LED there. We can also, zoom in and see that. So right there, the blinking blue LED shows that we're getting a heartbeat from the frontline server. And of course, the rover is wireless. We are using a Wi-Fi module from Microchip using the USR RS232T series. Now here we also have the setup. Let's go ahead and zoom out. And in this setup we have again the PIC32 as the main processor, and basically the I2C bus. The joystick is connected to this system through an I2C 4-channel ADC plus a DAC. So we're reading the potentiometers on the joystick through the I2C slave, which is using an Ionotronics circuit board for that, and its address is 4F. Now we also have ways to control through these knobs, also in addition to the joystick. So here we have a blinking LED, and this also shows that the joystick is on the network. So basically this system with a joystick and all these other controls is on the networked robots SIST platform, and we're getting the heartbeat, as is the rover. Now the key thing we want to demonstrate here is that through Java code, which we show over here, we're able to make a connection to the platform here that supports the joystick. It has its own unique 48-bit address, MAC address, and as well as a IP address, as you can see. And the rover also has MAC address and its IP, and basically the frontline server goes to the database table, and we can say make a connection using this ID. We don't have to know about the IP address. The frontline server gets that information from a database table using MySQL as a database, and gets the IP and makes a connection to the multi-threaded server, Wi-Fi server, the multi-threaded server and the Wi-Fi module on the rover, as well as the control console here. So this is very interesting because basically we're using the same electronics that is on the rover as well as on the console. And they also have the Morse code capability, where you can send Morse code, basically characters, and it plays it out of Morse code and beeps. This is very good to alert and also see, get confirm communications. So here we are, ready, set, go. And what I'm going to do is tell the rover to go forward. So I'll pull this way, sort of backwards, which you can see from the tires. We're going forward on the rover. And if I release the joystick, we stop. Now it gradually stops, but if you just release the joystick, the position of the joystick is stop. Let's go ahead and go reverse. So you can see that. I can also slow it down, with a joystick, you can see here, and then speed it up. Now let's go ahead and check tanking. So again, when you want to stop, just release the joystick. And for tanking, I'll do a twist in place. You'll see right here, I'll twist in place like this. So let's go ahead and look at the rover while I twist the joystick. And now we're tanking. You can see that one wheel is going in, two sets of wheels are going in one direction, the other in the opposite direction. And of course I can slow it down and tank slowly. Now this rover here is equipped with quite a bit of electronics. It also has the Polulu 100:1 gear ratio motors that also include the optical encoder. So this rover, we can individually measure the revolutions per second on each wheel independently, and we can graph that. And of course, through the network of robots, obviously we can monitor that from multiple entities. Okay, so the next step, what we're going to do is put the rover on the ground, and we'll control it with the joystick. Now in this case, instead of the power supply that you can see here, we're going to use a 12 volt 2800 milliamp hour battery. Okay, in this demonstration we've set up our networked robots, and we're able to talk to the rover with a joystick in order to control it through a joystick using a platform, a PIC32 platform with Wi-Fi that's on the network robots platform. We're connected to the rover using the frontline Java server. You see that we got the blinking LED blue showing we're on the network, and we can also show that over here on the joystick, and there's our joystick. So we're going through a Java application that basically makes a connection through the WebSocket API to the joystick platform. It also makes a WebSocket connection to the rover through the WebSocket API, and also only using the 48-bit unique MAC address of the rover, and also the 48-bit unique MAC address of the joystick platform we have here with a PIC32 and Wi-Fi. And every device on the network has an associated 48-bit MAC address, which we use for identification. So here we are. You don't need to know the IP address, just the 48-bit MAC address. And then we have a database table that the frontline Java server accesses, and using the MAC address, it associates it with the IP and port number and does all the routing. We have our Java WebSocket server router for the networked robots, and all this makes the connection. So we're ready to go. So in the joystick, if I move it this way, it's going to go, the rover should go forward. And let's go ahead and take a look at that. Here we go. Of course, it's pretty fast, so I stopped it. Let's go reverse. Stop it. Okay, let's go forward. Let's go slow a little bit. This is all with a joystick. Okay, let's go back a little bit. Okay, now let's go tank in place. I'm twisting the joystick, as you can see here. Okay, all right. Yeah, these are high torque motors, so this does a good job on the carpet, no problem whatsoever. Let's stop it, and let's go reverse a little bit. Stop it, go forward. Stop it. Okay, let's go reverse. Let's go a little slow. We can control this guy. Let's go forward real slow. And then stop. And then tank. Okay, so basically this is a demonstration. We have one entity, which is the joystick platform, which also is based on the PIC32 and running our RCP with its own Wi-Fi module with its own 48-bit MAC address. We have the rover with its 48-bit MAC address and IP, and then through the networked robots platform, they get connected, and basically we have Java code dedicated to this that connects the joystick to the rover. And obviously we can connect the joystick to any other rover. In fact, we show the rovers over here. Let's go ahead and zoom in. So here's a bunch of rovers. These are tanks and a little rover there. We also have these tri-tracks, and these guys of course are using some high torque motors also. and 2 of them, and we also have a tank here, and that has been adapted to use the polluter motor with the optical encoder so we can read the revolutions per second, and that includes these 2 robots. Let's go ahead and scan out. So all these guys are on the network, so the joystick can control either one of them by just specifying the 48-bit MAC address. Okay, since they're all on the network. And basically we have the access point over here, and the big box there is the Linux platform that hosts the network robotics platform enterprise application, all written in Java, and we host both the frontline server and the WebSocket server, and we communicate through the WebSocket API to talk to individual networked robots. Okay, this concludes this demonstration. Okay, we'll do some more shots of tanking. Here we go. Release the joystick, stop. We're going to go forward, fast, stop, and then reverse. Stop. Now let's go reverse slow. Okay. Then we go forward, full speed. Stop. Okay. So full control of the Rover again with the joystick shown over here. And it's connected through I2C bus to the platform, which is our console platform. We have basically the PIC32 and the Wi-Fi unit right there. The switches, of course, are set to operate in the RCP mode, which is the remote robotics control program. There we go. So some more action. Let's go ahead and go reverse on this guy full speed. I'm going to release, stop. Let's go forward, stop. Okay, let's go a little bit back. Get a nice location, and let's go tank. All right, that concludes this second demonstration of the joystick control of the Rover through the network robots platform.